Welcome back, everyone. So we said in the previous video that there are three kinds of strong electrolytes: strong acids, strong bases, and those ionic compounds that are soluble. So in this video, we're going to talk a little bit about how do we determine if an ionic compound is soluble. And as a refresher, when we say soluble, that means if something is soluble, that means that species dissolves in water to form solutions, and we give it the state AQ for aqueous. Things that are insoluble, those don't dissolve in water, and their state in the water is S, or solid. So that S does not stand for soluble. The state of S stands for solid. Insoluble. So how do we determine if an ionic compound is soluble? Thankfully, someone has been nice enough, aka MindTap, and other chemistry texts, to create tables, specifically a solubility table that can be used to predict if a compound, specifically ionic compound, is soluble or insoluble in water. And even more better news is that that solubility table will be given to you for the exam. You don't need to memorize it, but you do need to know how to use it to determine if a molecule is soluble or insoluble. So this is the table that is in your MindTap text that summarizes the solubility rules. I will give you a copy of this when we take the Unit 2 exam. If you took Intro Chem, at least for me here at Rose State, you saw a very similar solubility table to this. I can give you that one as well when taking the exam. They both contain the same information. But using this one, let's talk a little bit about how do we use this information to determine if something is soluble or not. And so looking at these rules, you see they are classified or categorized with two main headings, things that are soluble and things that are insoluble. So when presented with a molecule, you look to see which column it lies under, and most of the classifications are done by anion. So you look to see where that anion falls, either under soluble or insoluble. Some of them are listed by cation, but the majority of them are listed by anions. Once you find where your compound resides on the solubility table, you need to make sure you travel over to see if there are any exceptions to that solubility rule. So for example, if I was to give you the species, we will see this species again in some other examples, Pbi2, lead to iodide. And if I was to ask you, is this soluble or insoluble? Well, you see, oh, here's iodide. Because what I'm looking at is an iodide salt. So this Pbi2 would fall in this category, which is under soluble. But when I travel over to see if there's any exceptions, I see, an exception is compounds containing lead, 2+, and those guys are insoluble. So this molecule, Pbi2, is actually insoluble, and species that are insoluble get the state of S. So when given a molecule, you look to see where it falls on the solubility rules, making sure that you travel over to see if there are any notable exceptions. So on the next slide, we're going to use that solubility rules to determine if these guys are soluble or insoluble. We already said that Pbi2 is insoluble. But let's go ahead and let's do these others. I would encourage you to stop the video and predict on your own and then double check your answers. But looking at the solubility rules and these molecules, you should see that magnesium bromide is soluble. We already said lead 2 iodide is insoluble. Ammonium carbonate soluble. All ammonium salts are soluble. But the strontium hydroxide is insoluble while the zinc sulfate is soluble. So you should feel comfortable, given a chemical formula like these, be able to determine if something is soluble, and that means it has the state of AQ, or if something is insoluble, given the state of S for solid. And you should also feel comfortable being able to take that species, because this is a scale we'll use with the double displacement reactions. You should also feel comfortable taking species that are soluble and identifying what ions are present. So specifically, let's look at MgBr2 as an example. We already said that this is soluble, this is aqueous. If I was to ask you what ions are present in an aqueous solution of magnesium bromide, you'd have to say, oh, well, the cation, that's the metal, that's Mg, magnesium, and I know magnesium is in group 2, so it's a +2 charge. The anion is not Br2. That 2 there is present to balance out the charge of that molecule. The actual anion is present is just Br, bromine. And since bromine's in group 7, it has a -1 charge. So you should feel comfortable identifying if an ionic compound is soluble or insoluble, and identifying which ions are present in an aqueous solution of that species. That skill is really going to be helpful to you when we start to delve more into double displacement reactions, which will be the subject of the next video.